When you make a JNI call from Java into native code, the JVM has to know exactly which Java class and which native method signature is being referenced. If the class loading process doesn't match what the native side expects, the whole thing can crash. Here's what happens internally. When the JVM loads a class that declares a native method, it doesn't immediately know where that function lives. The link is resolved when the native library is loaded, and the method name plus its signature are matched to a native symbol. This is done either through system.loadLibrary or explicit registration via JNI_onload. Now imagine if you have multiple class loaders. This can easily happen in modular applications, application servers, or OSGI containers. The same Java class may be loaded more than once, each by a different class loader. From the Java point of view, those are different classes, even if the bytecode is identical. But your native code might only have registered the method with one version of the class. If the JVM later tries to invoke the method on the other class loader's version, the native symbol is missing. The JVM then fails to find the function pointer, which often results in a fatal error. Another common pitfall is a signature mismatch. If the method declaration in Java says one parameter type, but the native function was compiled with a different signature, the linker can't line them up. The JVM expects the call frame to look one way, but the native code assumes a different layout. That mismatch usually causes segmentation faults. Finally, if you forget to include your native library path correctly with -djava.library.path, or you use system.loadLibrary in the wrong class loader context, the JVM may load the library too late, or not at all, leaving the native method unresolved when it's first called. Again, the result is a crash. The takeaway is this: class loading and JNI are tightly connected. Always make sure your class loaders are consistent, your Java method signatures match your native functions, and that your library is loaded in the right context. Otherwise, you may see mysterious segmentation faults that are really just class loading problems in disguise.